So students, till now we did a detailed study on limits and continuity. In this next slide we are going to do the knowledge about LHopital's rules and its various applications, so stay tuned for it. Okay, so after doing the topics like limits, finding out its value and infinite limits along with continuity, we have come towards a point that uses the theory that we have read in limits and continuity towards an application point. So let's get started with LHopital's rule, and there is very special story with it. This is the person who has found out the LHopital's rule. Now actually what has happened, LHopital was his student of his teacher Johann Bernoulli, and this rule was basically developed by his teacher. But what he did, he paid Bernoulli for private lessons and then published the first calculus books in those lessons. So he was a very intelligent student and this person was a very generous teacher. So let's see what do we exactly get in LHopital's rule. Suppose we have to find out the value of this function as a limit when x approaches towards 2, and this function is x square upon 4 upon x minus 2. So what we will see, if we will directly try to find out the value of this function using the methods of substitution, I will put x equal to 2 in both the cases. I will get the value 0 in the numerator and 0 in the denominator, which will give me a format 0 upon 0, and this is known for sure that 0 by 0 is an indeterminate form. I cannot exactly find anything. So as explained by me right now, that is indeterminate form. So how we will find limit in this case? We can find out limit by factoring the numerator. As I can see that it's a square minus b square, that is it can be factored into x plus 2 and x minus 2. That is what we did. Now what we'll do, we'll cancel out the common terms, and x minus 2 is common both in numerator as well as in denominator. So finally we are left out with a linear function, that is x plus 2, and we have to find out the value of limit when x approaches towards 2. And this is very simple, and we'll use the method of direct substitution while calculating the value of this function, and the value will come out as 4. I think this is clear now. So, but suppose we have a general function fx and gx, and we have to find out the value of limit at x tending to a. In exact terms, I can say that the limit is actually the ratio of the numerator over the denominator as x approaches 2 in this case, right? Suppose I have a curve of x square minus 4 and this is a straight line representing x minus 2. So what will I see? That zooming in this function to a very close value, I will get that the value of the function x square minus 4 and x minus 2 when x is approaching towards 2 coincide towards a point that is 0 by 0. So that is the value. So what we are doing now, this is the value of when I am approaching towards x is fx, and when I am approaching towards value of g, that is gx. So fx upon gx is the standard value that I have got. Now what happens when x tends towards 2, fx by gx becomes df by dg, and df is a small incremental change because this is the approaching concept, and approaching means the difference between the value of x and towards the value which I am approaching is very small. So the difference will become infinitesimal and it will be df by dx. This can also be written as df by dx and dg by dx, and I know that df by dx is generally the slope of the function and dg by dx is generally the slope of the tangent. So limit fx upon gx when x is tending towards a, when equated to limit x square minus 4 upon x minus 2 when x is tending towards 2, can be written as d by dx of the numerator function upon d by dx of the denominator function. So if we will do the differentiation of the numerator, what we will get, we will get 2x, and the differentiation of the constant part will be 0, and for the denominator the differentiation of x with respect to x will be 1 and the constant part will come out to be 0. And now this is a linear function as we can see, and now we will apply the method of substitution with which x will be directly placed as 2 and this function is going to give me a value 4. So now what we have seen, the value calculated from this method and the value which we have calculated by using factorization, both of them are coming out as same. So now we can make a standard definition out of it, and that is if fx upon gx is a rational function, and we have to find out the value of limit when x tending towards a, and adding to that this value is indeterminate, then the limit of this function will be equal to the limit of f dash x upon g dash x when x is tending towards a. This is a standard definition in terms of mathematics as far as LHopital's rule is concerned. So as if we have just now defined LHopital rule, so we will now verify it whether the definition of the rule is correct or not, and we will do the proof of the definition in a retrograde synthesis. Means I'll start with the final result and I'll make out the question. Suppose I have given f dash a upon g dash a. So using the very first law of fundamental law of calculus, what I can write f dash as fx minus fa upon x minus a when the limit of x is tending towards a, gx minus ga upon x minus a when x is tending towards a. From this, x minus a and x minus a will be cancelled out, and I'll be only left with fx minus fa and gx minus ga, and as defined earlier, the value of both of these functions is 0. That is why it is becoming indeterminate at that point. I am left with the value fx upon gx when x tends towards a. So what we have just proved now, that the value of the function fx upon gx when limit x tending to a is equal to the value of f dash x upon g dash x when x is tending towards a. Now let's take an example. Suppose you have a question that 1 minus cos x upon x plus x square is the given rational function, and in this case you have to find out the value of limit when x is tending towards 0. So what we'll do, we'll differentiate the numerator and the denominator separately with respect to x. So the differentiation of cos x is minus sin x, and along with the minus sign, minus into minus will become plus. X will give me 1, x square will give me 2x, and the plus sign will be retained. So now I will see that if I'll directly substitute x equal to 0, this is going to give me a value 0 upon 1, right? So the value of the limit of this function is 0. And there is very important thing that you must consider while using LHopital rule, and that is, if it's no longer indeterminate, then you have to stop, and the value which the function is going to give you will be the final limit. And even if you are not stopping when the value is not indeterminate, you will end up with a wrong answer, as you can verify with this case. Suppose you have differentiated it again, so this will be cos x upon 2, and the value of this function will come out as half, so which is not the value of the limit. So this will lead you to an erroneous result. So while applying LHopital rules, it is mandatory to check at every step whether the given value of the function is giving you indeterminate value or not, which is wrong as explained. So on the other hand, when you are going to apply LHopital rule as many times as necessary, only and only when the fraction what we are getting is coming out to be indeterminate. Let's take another example. Limit x tending to 0, root over 1 plus x minus 1 minus x by 2 upon x square. If I directly substitute x equal to 0 in this case, I will see that the form that this function is taking is 0 by 0. And now what I have done, I have written this function in exponential form. Now I will take the differentiation of both numerator and denominator separately, because I can apply LHopital's rule, as I can see that the format which this function is taking is 0 by 0, and that is indeterminate. So after doing the very first differentiation, when I am applying the value of x to be 0 again, I am seeing that the value of this function is coming out to be 0 by 0 again, and that is also an indeterminate form. So I will do the differentiation second time. After doing the differentiation one time more, what I am seeing is that the value that this function assumes is now not 0 by 0, while the value that this function takes is minus 1 by 4 upon 2, and that is minus 1 by 8. So the value of the limit of this function when x tends towards 0 is finally minus 1 by 8, as found out using LHopital's rule. And the application of LHopital's rule is not only for the 0 by 0 undeterminate form. There are various other undeterminate forms which we can use LHopital rules to find out, such as infinity by infinity, infinity into 0, infinity minus infinity, 1 to the power infinity, 0 to the power 0. All these forms are considered as indeterminate form in limits, and also infinity to the power 0. The first one, infinity by infinity, can be evaluated just like 0 by 0, because we know that infinity is 1 by 0, and if I am going to write both the numerator and denominator as 1 by 0, 1 by 0, I'll finally lead up to this position where like this fraction will be equal to 0 by 0. And similarly, the application of infinity by infinity conversion towards 0 by 0, we will try to convert other terms to fractions first. And how to get that? Let's take an example. Suppose I have a function x into sine of 1 by x, and I have to find out the limit of this function when x is tending towards infinity. So what I can see is that if I directly put in value of x as infinity, this is infinity, as sine is a function which is always going to give me value between minus 1 to 1, but this is going towards 0, so this will be approaching towards 0, and this is approaching towards infinity. This is infinity into 0, this is indeterminate. So what will I do? I'll try to write this function with a slight modification as sine 1 by x upon 1 by x. This also approaches 0, 0. See, the theory which I explained in the last slide is that any of the given indeterminate form, the first thing that we are going to do is we will try to convert this into fractions, because we know that L'Hopital rule is only applicable when we have a rational function. This is not the format in which I'll consider this function to be rational. So what I've done, I've converted this function into a rational function, and this function is giving me an indeterminate form, so L'Hopital rule can be applied to this function. But there is a standard result that we know: when the limit x tends to 0, sin x by x always gives the value 1. But in this case, we would love to find out the answer using L'Hopital's rule. So how do we do L'Hopital's rule? We'll take the differentiation of sin 1 by x. So first of all, the outer function will be differentiated. The differentiation of sine will give me cos 1 by x, and then will come to 1 by x. The differentiation of 1 by x will give me minus 1 by x square, and in the denominator, the differentiation of 1 by x is going to give me minus 1 by x square. So this thing will now be cancelled out, and I'm only left with the limit x tending to infinity cos 1 by x, and I know that the value of cos 0 is 1. So the value of limit of this function when x tends to infinity comes out as 1. Suppose you're taking another function. This is a function in which the indeterminate form will be of the form infinity minus infinity. Let's see how. 1 upon ln x minus 1 upon x minus 1. As we know that whenever x approaches towards 1, the value of log becomes 0, and 1 by 0 is infinity minus. This is a rational function with numerator as 1 and the denominator as a linear function x minus 1. So if I'm going to put x equal to 1 over here, this will also give me 1 by 0. So this is infinity minus infinity, one of the indeterminate forms. So my main motive in this case will be to convert this into a single fractional function. So let's see how we'll do that. I'll take the LCM, and the LCM will turn out to be x minus 1 minus ln x, and in the denominator I'll have x minus 1 into ln x. Now this form can be seen as 0 by 0 indeterminate form. So what we'll do the differentiation and apply the L'Hopital's rule. The differentiation of x is going to give me 1. The differentiation of constant term will be 0. ln x gets differentiated and gives me output as 1 by x. This is a product function, so the rule of product for finding out differentiation will be applied over here. First of all, we'll take x minus 1 as constant and do the differentiation of ln x, so that will be 1 by x, and then I'll take ln x constant and do the differentiation of x minus 1, so that will be 1. So this is the final output in which we get a rational function in single format, where the numerator is 1 upon 1 minus x and the denominator is x minus 1 by x plus ln x, where x tends towards 1. Now I did the simplification, and after modification, what I've got x minus 1 upon x minus 1 plus x ln x, and if I'll put x equal to 1 in this case, I will see that this is still 0, 0. So what will I do? I'll do the differentiation once again. Now I'll see that this numerator is 1 and the denominator is 2 plus ln x. Now if I'm going to put x equal to 1, the value is not 0 by 0, but this will be a constant finite value, that is half. So I can conclude that the limit of this function when x is tending towards 1 is going to give me a value that is half. Now there are other indeterminate forms such as 1 to the power infinity, 0 to the power 0, infinity to the power 0. We'll see how we'll convert this given indeterminate forms into fractions and then the application of LHopital's rule towards it. Suppose you have a function ln u to the power n and that will be equal to n ln u as one of the properties of log. So this is a product. What we can do, we can write it in the form of fractions. So in fractions it will be written as ln u 1 by n. So converting it to a fraction is only for the cause because we want to apply LHopital's rule in this, and this format of the function is not permitting me to use LHopital's rule. That's why this conversion has been done. Suppose you have a function fx when x tends to a. So if this function is of the form indeterminate, infinity to the power 0 or 1 to the power infinity, where you don't have any method to find out value of limits. So what we'll do, we'll raise this function as ln to the power e, as we know that this e can be taken out over here and this will be 1, and after doing a bit modification I'll be left with this function. So now after that, what will I do, using the properties of log, I can take out this limit outside and this will be e limit x tends to a ln fx, and then I'll try to find out this complete format in form of fractions with which I'll apply the LHopital's rule, which will give me the final answer. Let's take an example. Suppose I was having x to the power 1 by x and x was tending towards infinity. Now this is the function which is of the indeterminate form, infinity to the power 0. So what will I do? I'll exponentiate this function e to the power limit x tends to infinity ln x 1 by x. This is in power to this function, so this will come outside of the log. After that, what will get, e to the power limit x tending towards infinity 1 by x ln x. Now I can apply LHopital's rule in this format. So this will be e limit x tends to infinity ln x upon x, and I can see that x tends to infinity is going to give this value infinity, and this is infinity. So this is infinity comma infinity or 0 by 0. After application of LHopital, what I will get, 1 upon x. So the final format will be 1 by x into 1, and after application of x as infinity, the value of this thing will convert towards 0, and this will be e to the power 0, and we know that any number raised to the power 0 will finally give us value 1. So the limit of this function when x is tending towards infinity is 1. So I think this was all regarding LHopital, and this was clear. For more examples and applications, tune in to askIITians.com. So hi students, now as if we have completed the topic, in case of any doubts and queries, what you can do, you can post your question for free on discussion board of askIITians. To do so, it's very simple process. First of all, you'll type www.askIITians.com in the address bar of your browser. Now you'll get towards this page, and in this page you'll find discussion board. You will click on that and it will take you to a page where you can ask your questions from the expert. First of all, you can select the category with which from where you want to ask the question. You'll post your question and then you'll click on the get answer button. We experts at askIITians will revert back to you in 24 to 48 hours with the answer of your question. I hope this process is clear. So hi students, this is the concluding session of this presentation. Today what we have learned, we learned the topics limits, continuity and LHopital's rule in detail. I hope you have learned as well as enjoyed these sessions. Stay tuned for more lectures on PNC and sequence series on askIITians.com. Thank you.